History remembers developers who use sound strategy to achieve grand results. Well, that's true, and it's also true that we can just copy and paste from Stack Overflow and call it a day. Well, in software development, excelling at problem solving requires a good strategist, and there are many strategies we can use to solve a variety of problems. One of the most common strategies for designing algorithms is iteration, which is our topic for this video. Iteration consists in using loops to repeat a process until a condition is met, and there's a good chance you're already using it in your code. When we iterate, our program tracks which step is currently being executed, and each of those steps is called an iteration. This makes iteration strategy great for running through an input and applying the same operations on every part of it. Let's take a look at an example and see how we can use iteration to merge two alphabetically sorted lists of food. We can iteratively compare the top items from the two lists, and the greater one alphabetically will be added to our merged collection. So if we compare apple and broccoli, apple will be removed from its collection and added to the merged collection. As a result, carrot will be the top item in the fresh food collection. We do the same again, comparing carrot and broccoli this time, and then we remove broccoli and add it to our merged collection. We will then repeat the process until we have all the food items in the merged food collection. The pseudocode for this process can be written using a loop, and it will look something like this. First, we define our merge function, which will take two arguments, fresh and frozen collections. Then, inside of our merge function, we create a new list for serving our results. With that, we then implement our iteration strategy using a while loop, which will continue to execute provided that both the fresh and frozen collections are not empty. And with each iteration, we will compare the top items from each collection. In this case, if the top item from the fresh food collection is greater alphabetically than the top item from the frozen food collection, then we remove that item from the fresh food collection and assign it to our food variable. But if the top item from the fresh food collection is not greater alphabetically than the top item from the frozen food collection, then we remove the top item from the frozen food collection instead and assign it to our food variable here. After the if-else statement, we then append the food item to our results collection and repeat the process provided that the condition for our while loop is still valid. Finally, when the while loop completes or finishes executing, our merge function will then return the results list. Let's see how we can implement this merge function in JavaScript. So we're going to start by defining our two sorted food collections as arrays of strings, and then we can implement our merge function. So let us define it here, and let's name this merge food just to be a little bit more descriptive. And this function will take two arguments, and both of them will be arrays of strings. So the first one will be for our fresh food collection, and the second one will be for our frozen food collection. Now that we have this, we can implement the rest of the logic for our merge food function. So we're going to start by creating our results collection for our merged food items. In this case, it will be an array. So let us define it here, and we're going to name this merged and then initialize it as an empty array. And with this, we can now implement our while loop that will execute a block of code provided that both our fresh and frozen food collections have one or more food items. And to do that in JavaScript, we can simply check for the length of each of our collections. So we can say while, and then check for the length of our fresh food collection first. So let us check for the length there, and we need to do the same for the frozen food collection. So this will ensure that the while loop will only execute provided that both of these collections have one or more food items. So now that we have this, we can utilize an if-else statement inside of our while loop to compare the first items in both collections. In this case, we want to check if the first item in the fresh food collection is greater than the first item in the frozen food collection alphabetically. And if the result is true, we will remove it and then add it to our results collection, which is the merged array here. But if the result is false, we will remove the first item from the frozen food collection instead and then push it or add it to our merged collection here. So for that, we're going to need to check the first item from our fresh food collection. And again, since this is just an array, we know that the first item will always be at index 0. And in this case, we want to check if it's less than the first item from the frozen food collection. And if this is true, we're going to do something else here. And if it's not, we're going to be using our else clause to do something else here. So in this case now, we're going to utilize two functions provided for us in JavaScript for arrays. The first function is push. push will add one or more elements to the end of an array. And the second function is shift. Shift will remove the first element from an array, and then it will return the removed element. So in this case, what we want to do for the first, if the condition is true here, we want to say merged, and in this case we want to say push. But what we want to push here is the first element that we'll remove from our fresh food collection, and we'll do that using shift. So we just call shift on our fresh food collection. And once we have this, we can copy this line here, because we want to do the opposite in the else clause. But in this case, we want to be removing from the frozen food collection. So once we have this, our function now can return the merged collection or the result. And let's test out our function and see the results that we get from this. So for this, we're going to create a new variable here that we can call result, and result will be the value that will be returned from merged food. And here we need to provide the required arguments. So the first one will be the fresh food collection, and then the second one will be the frozen food collection. And we can simply use console.table to print out our result. So console.table will just display our data as a table. So that will be perfect for us. So let's save this file and then open our terminals, and then we can test this. So node index.js, run this, and then we get our results. But one thing you might have noticed is with this result, some of the food items are actually missing. For example, we can see that we don't have potato and watermelon from our fresh food collection. And the reason for this is that the while loop stopped executing when one of these collections was empty. So in this case, the frozen food collection didn't have any food items, and then this stopped. So to address this edge case, what we need to do is to check for both of these collections to see if they still have more food items. And if they do, we need to add them to our merge collection. So let's start by checking our fresh food collection first. So in this case, we want to check for the length again. And if it still does have one or more food items, we want to add them to our merge collection. So what we can do is copy this line here and then just paste here, because that's what we want to do. And we can duplicate this while loop here and then just change a couple of things. First, we just want to check now the frozen food collection and also remove from the frozen food collection here. So make sure that when you're checking from the fresh food collection, you're also removing from the fresh food collection, and the same applies for the frozen food collection. And with this, we can save this file and then again open our terminal and then again run that application to try and see the results. And now you can see that we have potato and watermelon as part of our merged collection, and that's 10 food items in total. So our merge algorithm is a linear time algorithm with the time complexity O of n, as it loops through all the items in the input while performing a fixed number of operations for each food item. This means that the running time increases the most linearly with the size of the input, and from this we can see that there is a constant c, such that the running time is cn for every input of size n. So what are your thoughts on the iteration strategy? Let me know. That's been it. Thank you for watching. Hope you found this video useful. Do subscribe to the channel if you haven't already, and I will see you hopefully in the next video. Datenda, good day.